So just keep in mind that we reserve the right to change that later, depending upon how we want to handle acceleration.
Negative acceleration.
So you want to,
Wait, I don't know if mine's wrong or right.
all right, it could be either way. If you just leave it like that, then we're making the assumption acceleration is in that direction. We know it's not. We know acceleration is that way. So if we leave it like this, then acceleration will end up being a negative number. And that's fine. Acceleration can be negative, just says, oh, it's the other way. If we put the negative in here, then I would expect A to be a positive number. So it depends upon if you want acceleration to be a negative number or a positive number. Stone, it was your equation. We can put the negative in here or wait and get the negative at the end.
I always put the negative in there.
Okay, so technically then,
Oh wait, no. Like how it is.
as it is?
Yeah.
Okay, so I'm expecting acceleration to be a negative number. All right, next. That was, Stone got his done. Someone else want to volunteer?
I'll try it.
All right, Tanner.
So I had 5B W5 cosine theta minus F
Wait, W5, which one?
cosine, I think.
You're doing I?
Oh, so it'll be sine theta.
You want to do J? Okay.
I mean, I'm not sure on either one. I was just throwing it out there so I could call them. Minus F equals mass times acceleration.
This would
And
be,
I was about to say, we can make that one negative if need be. I think it needs to be negative. The acceleration,
all right.
in the question.
If we're gonna make this one negative,
Oh, we gotta make both of them negative. Oh,
That
no,
one
please
has-
keep rolling then.
okay. There are two issues though.
Yeah. No.
They're all going.
Pardon?
They're all going opposite of I-5.
Therefore,
So they should all go negative.
that should be, all right, that's one
Okay.
issue.
And then there should be tension.
Yeah, minus FT. Yeah, there are three forces in the negative I hat direction. All right, there we go. Now we're good. If you put a negative in here to make that a positive number, then we're, in essence, we are flipping I-5 into the other direction, so all those become positive.
Yeah, come next Monday, I'm not gonna remember any of that.
It'll just be natural. It's not a matter, it's like, do you remember your parents' names? I mean, sorry, do you memorize your parents' names? No, you just know it. So I'm assuming you mean that by Monday, you'll just know it.
Yeah, that's.
On Monday is just chapter 2 and 3, right? Or
Yeah.
is it with?
It is chapter 2 and 3.
Okay.
So I guess you don't need to have that memorized or know by Monday. One more equation to go. Dominic?
0.5 cosine minus the normal force y5 is equal to m5a.
Is that what you said? I heard it correctly, right?
Yes.
Two issues.
I think the right side of the equation is wrong.
That is correct.
I just don't know what it is.
Oh.
Negative weight 5 cosine and plus.
That's the other one.
Plus.
The way that we have the convention set up is that that's the positive direction.
Oh, yeah.
All right. So we have that side, but now the right-hand side.
Is acceleration supposed to be 0?
Yes. Because the acceleration, we have it set up so that acceleration is in the I hat
Right.
direction, so therefore it's
It
0
can't
there.
go into the ground.
So 0. All right, we have our equations now. Substitution. For what do we have an independent formula? In other words, we have formulas for some of these variables, which are going to be true regardless of the problem. And tension does not have an independent formula. It's always problem specific.
Friction.
Yeah, so what kind of friction are we dealing with here?
Kinetic.
Yeah, it's already sliding, it's given in the problem. What's the formula for kinetic friction?
U of K times normal force.
All right. So we have a substitution for that. And what is the other independent formula we have?
Weight.
That's not scratch.
Acceleration.
Did I mess it up?
Thank you. Or you just said FG, I'm gonna go. All right, so we got, oh, I'll do that one. There we go. All right, so we're gonna make a substitution for those. So we end up with negative M5G sine theta minus mu K Y5 minus the tension is equal M5A. We have negative M5G cosine theta equals, I'll make that positive, make that a Y5. I'm just bringing this over to the other side and then flip it. FT minus M3G equals M3A.
What's the reason for the second equation being positive at the start?
Well, I have some of these, I have this negative number plus this positive number is equal to 0. And so therefore, Y5 has to be equal to W5 cosine theta.
Okay, yeah.
Just to, I'm gonna rewrite that equation. If you have it written down, don't feel the need to have to rewrite it yourself. So we have Y5 equals M5 cosine theta. If we just add that to both sides.
Right.
Now we just go about solving it. First off, I'm gonna throw that in for Y5. So this equation becomes negative M5G sine theta minus mu K M5G cosine theta minus the tension is equal to M5A. And my other equation, I have tension minus M3G equals M3A. And now I just add them. Because there are many ways of solving it at this point. Some students prefer substitution. They'll isolate FT and then plug into here. Personally, if I have negative FT and FT, I'm just gonna add and get rid of them. So I'm left with negative M5G sine theta minus mu K M5G cosine theta minus M3G equals M5A plus M3A. And so we end up with the absolutely spectacular equation of my acceleration is going to be negative M5G sine theta minus mu K M5G cosine theta minus M3G divided by M3 plus M5. was that a hump?
Okay.
Yeah,
So are you just combining
the left side and the right side.
the 5 mass and then you're leaving what are you doing with the I-hat for the 3 kilogram mass equation? Where did that go? Where have we not gone?
The I3 hat
Yeah.
equation, this one?
Yeah.
So this is the I3 hat equation right there.
Okay.
This is the combination of I hat, J hat for the 5 kilogram. And then when I added it, I have an FT and a negative FT, and they'll cancel out when I add the left sides.
Okay, wait. So, why is the cosine on like the top equation, why is that negative? Like multiplied?
Why is that a negative sign there?
Yeah.
Because there's a negative sign there.
And then multiplying that would make it, I'm just saying like we made the J5 hat, positive, right?
And positive, we say J5 hat was in that direction, so my positive, so when I set up my equation to start with, that's positive and that's negative.
Okay, I thought we switched, never mind, I thought we switched it to positive earlier. So I was confused.
Originally, this was positive and that was negative, but then given our convention, that
Okay.
really should be negative, that should be positive.
Okay.
It's equal to 0, so you get away with either one.
Can you explain it in terms of like, do we add like the I-hats together, or the mass 5 together and then add the mass 3? Or like,
You're talking when I go from here to here, or earlier?
like kind of all of it to get to that at the bottom?
All right, so technically, what I'm doing here, this is the long version. I have to add these forces together. So I have Y5 J hat plus negative W5 cosine theta J hat plus negative W5 sine theta I hat plus negative FT I hat plus negative F I hat is equal to mass times A I hat plus 0 J hat. That's M5. That's just the sum of all the forces is equal to mass times acceleration. If I sort this, I end up with Y5 minus W5 cosine theta J hat plus negative W5 sine theta minus FT minus friction, technically that's okay, I hat is equal to M5A I hat plus 0 J hat, if I distribute. If this is true, the I hat, since I hat and J hat are independent of each other, they are perpendicular. If this is true, then that I hat component must be equal to that I hat component. That J hat component must be equal to that J hat component. Which just gets us these two equations here. So at this point, once we recognize that the coefficient of I hat here equals the coefficient of I hat here, we've taken the vector part out of it, and we're left with this equation right here. And then, well, there's only one direction for the other one, so we get this. So now I've got 3 equations, it's a matter of trying to isolate it down. W5 I can find easily enough. Well, once we make the substitution, I know the mass, I know G, I know mu K, I know M, 5G, and 3G, 3. I don't know theta, I don't know Y5, and I don't know A. I have 3 unknowns. I have 3 equations, 3 unknowns. Now it becomes a math problem. Oh, wait, I do know theta. I know that. Oh, I don't know Y5, I don't know tension, I don't know acceleration. Those are the 3 unknowns. I've already dealt with the directions, so now just dealing with 3 equations, 3 unknowns, not worried about direction anymore. And then, I felt like that was where the big problem was, but do you want to re-ask your question?
I think you gave me what I need.
Okay.
So for the mu of k in the final answer, I was just wondering why is it grouped with cosine?
The friction force is here, UK times Y5.
Yeah.
From the second equation, I know Y5 is equal to M5G cosine theta. If I substitute that in for here,
Oh.
I have mu K, there's my, that's my Y.
For some reason I didn't connect that I was substituting it.
Okay,
Alright, all good now.
there are other ways of approaching 3 equations, 3 unknowns, so. And if you plugged in, you could use Kramer's rule, inverse matrices, plotting in 3-dimensional space. Probably not the easiest one. Other questions? Let's get an answer. So, now I'll plug in numbers. So A equals -5 times 9.8 times the sine of 30 degrees.
32.
Oh,
32, right?
32 degrees.
32. Oh, yes, thank you. Minus 0.2 times 5 times 9.8 times the cosine of 32 degrees minus 3 times 9.8 divided by 3 plus 5. And we get
So I wasn't here for this, but the 3 and the 5, is that how much the boxes weigh?
I identified the 3 kilogram mass and the 5 kilogram mass.
Okay, I didn't see that.
And so then, that was the problem, so then I just labeled it as 3 and 5.
Okay.
If that disturbs you, you can label it as A and B if you want.
No, that's fine.
Will the answer of negative 7.9596 make sense?
Negative 7.9596.
9596.
All right, so first off, at a cursory glance, we got a negative number as expected, so that makes sense. If I had them attached and the 5 kilogram mass were going straight up, what would be the acceleration? Assuming they're moving in the positive direction.
9.8?
Negative.
Well, if it's going up, because down would be negative 9.8, so wouldn't up be just positive 9.8?
It would be, but it's not accelerating upwards, it's slowing down.
Okay, oh, yeah.
So I would expect this to be less, not greater than the acceleration due to gravity, although it could be, given the setup. So on the surface, it makes some sense. Did anyone else get the same answer? All right, we got one other person with the same answer. Aaron, that's the look of you did not get the same answer?
I didn't do it.
Oh. So, any questions up to there? We found the acceleration. If this were a multi-part problem, I mean, if this were the problem, I would break it into parts, and one of the parts would be, what is the acceleration? And the next step is, how far up the ramp does it go? It's now a motion problem. I'm looking for displacement, no initial velocity, final velocity, acceleration, and time. Initially going positive 7 meters per second. My acceleration is negative 7.9596 meters per second squared. And I need 3 things. What's the third thing? Trying to figure out how far up the ramp it will go.
Well, if we're looking for how far up it's gonna go, we need to find, well, that would be the displacement.
Right, that's what we're trying to find then, okay. But I need to know either time or final velocity in order to solve it.
If it's going up to part, it reaches 0 and then starts going back down, correct?
Correct.
So the final velocity be 0?
Yes. So I can solve for time, and then I can use any of the cake formulas or any of the cake formulas that have displacement in it. Or I could just jump straight to displacement.
Yeah, just
So-
the fourth one,
Which one?
the fourth kinematic.
And what is the fourth kinematic equation?
The velocity final squared equals velocity initial squared plus 2a times displacement.
All right, I am gonna nitpick one thing there. Is this the final velocity squared?
Then there's be 0.
No. That's not the question of what the number is. The question is this the final velocity squared? Let me reword that. What is this? It is not final velocity